So we're going to graph y equals e to the x. So the very first question you might go is, what? What is that? What is e? Can you find it on your calculator? It's a number. It's a number. Yeah. Your English teachers all these years, lying. It is not a letter whatsoever. It's a number. Can you find that number on your calculator? Yes. What is it equal to? Approximately. 2.718281828, and it keeps on going, but it doesn't follow that pattern after that. It sure looks like it wants to, doesn't it? In fact, e is a number like pi. It's an irrational number. It's a special irrational number in that, just like pi, it shows up all over in real life, and it is weird. There it is, e. But it's easier to memorize than pi because of the pattern for the first 9 numbers, and then after that it's all random and weird as well. What is it used for? Well, e comes up in continuous growth questions. It comes up in calculus as the only thing whose derivative is itself. So when you said, what is it derived from, I kind of chuckled to myself, but that's a math joke. And so it's just a number. It's just a weird number, just like pi is a weird number. But when we graph this, the graphing is actually straightforward and easy. What point do you know that it's going to go through? 0, 1. What's another point that it goes through? 1, e. I know that's going to feel weird to label, but that's correct. You just have to estimate it at about 2.7. Has the same shape as all of our other exponential graphs. Has our asymptote at y equals 0, just like our other exponential graphs. And so now that you've graphed that one, you can now graph this one. And this is our last question for the day. I'd like you to graph 3e to the x minus 2 plus 5. So that's what happens after we've changed our points. We've multiplied our y values by 3. We've moved 2 to the right and 5 up. And now that we have that information, we can graph our asymptote at y equals 5. Our points, 2, 8, label that point, and 3, 3e plus 5. And so again, I'm just estimating where that 13.1 would be. And since it's going up, we can now graph it going through all of those points. So to summarize, if you're graphing an exponential function, you need to have 2 points labeled accurately and the asymptote labeled accurately, and then have the correct shape for the graph.